Hello, this visual abstract consists of investigation on the characterization and modeling of fracture process zone behavior in concrete beams subjected to 3-point loading test. Main objectives: already a lot of works carried out by using the traditional experimental methods to find out the fracture process zone. This involves the huge cost for carrying out experimental work. In this paper, effort has been made to find out the fracture process zone, its location, and what is the length of the fracture process zone, and how it affects the different size, the effects on the different sizes of the beams. Method adopted. In this study, spherical aggregates are randomly distributed using Monte Carlo method. Aggregates were randomly placed according to the gradation of the aggregate by using the Python script, and then analysis is carried out with the CAE software Abacus. Small size beam to large size beam considered for the study. Depth of 75 mm is small size beam, and maximum depth of beam is 1000 mm. Span to depth ratio, that is notch depth ratio, is kept as in 0.25, and then span to depth ratio is 3. Here in this table shows the different depth of notch adopted for the study. This figure shows the beam numerical model. Central portion is kept as a mesostructure. Interfaces between the aggregate and cement matrix, as well as cement matrix with cement matrix interface, has been shown in this second figure. Different loading steps adopted, shown in load deflection curve, and also at P6, P7, how fracture process zone take place, as shown in right side of the figure. In this figure, what we can observe, there is a maximum attainment of fracture process zone in between the loading step 6 and loading step 7. What we can observe here, length of fracture process zone is 47 mm, which is attained at the 26 percentage of post peak load for the beam, small size beam. Similarly, different sizes of beams, 150 mm, 250 mm, 500 mm, 1000 mm, we can observe the fracture process zone 92.33 mm, 127 mm, 172 mm, and 265 mm respectively. And also what we can observe, maximum fracture process zone length developed between the 20 to 26 percentage of post peak slope. Conclusions: what we can observe from this present study, fracture process zone deviate due to the presence of aggregate and as well as weak interfacial transition zones developed by using the cohesive zone model. And also this is because medium grade concrete is used, fracture process zone deviates. If it is in high strength concrete, there may be possibility that uh, this aggregates may be harder and it may penetrate through the aggregate. One more important point is fracture process zone increases initially and then it decreases as the load changes. And then length of the fracture process zone in small size beam is more compared to the length of the fracture process zone in large size beams. From this study, what we can see, new insight, mechanism of fracture process zone by using the modeling process, and we can observe also microcracking insertion and its propagation. Thank you.